Thank you for excuse me, joining me this morning for the presentation on collection and analysis of reduced sulfur compounds in air. Reduced sulfur compounds are of interest because of the low threshold and their concern to regulatory authorities and to the general public stems from mostly from their odors. Our reduced sulfur compounds can also cause headaches and nausea in many individuals, thus driving the interest for these compounds. Air regulations have been established based on the odor and toxicity of individual compounds. Approximately 60% of the total reduced sulfur released is comprised of hydrogen sulfide, and it is also the main driving force for a lot of the thresholds that have been established. Since we're in Ontario, there's a bit of focus on Ontario and Canadian regulations here, but in Ontario, it has been identified that approximately 74% of the total reduced sulfur is from the pulp and paper sector, and the rest is mainly from the iron and steel, petroleum refineries, municipal sewage treatment plants, and landfills. This slide sort of is a nice overview of some of the common sources of reduced sulfur compounds, and also highlights some of the individual compounds that are typically found in these sources. So as you can see, I'm not going to go through the whole slide, but for landfills, hydrogen sulfide is one of the predominant contaminants. Where if you look at sewers and waste treatment plants, you start to add in mercaptans and other dimethyl sulfides or trimethyls or dimethyl disulfides, etc. Reduced sulfur compounds can be found in a lot of different products as well as byproducts and processes, and thus they're not only of concern because of their presence in the environment, because of some of the sources, but also because of some of these reasons. Low levels of sulfur compounds are added to natural gas and liquid propane gases, and some of these compounds can react to form compounds that have lower odor thresholds, making it of more concern. Fuel gases are used in energy production or converted to new products using catalysts, and quite often these catalysts can be destroyed by the sulfur in the feedstock. So this can be an expensive byproduct of sulfur being present. Methane and other gas fractions in landfill gases are often burnt or sold to natural gas distributors, requiring their analysis for regulatory, production, or distribution purposes. I'm going to look a little bit at some of the regulations, starting with Ontario. For any of our customers in the U.S., I'm not sure exactly what the regulations are, but in some I've looked at, some of them are fairly similar to what Ontario has. Total reduced sulfur was incorporated into Ontario Regulation 419 about 2007 or so. And in Ontario, total reduced sulfur is defined as 4 compounds: hydrogen sulfide, methyl mercaptan, dimethyl sulfide, and dimethyl disulfide. And these compounds were included based on their pattern of use and toxicity of the compounds. Hydrogen sulfide is used as the surrogate for total reduced sulfur based on the health-based standards, because there's a lot of toxicological information available on hydrogen sulfide. In Ontario, there are 2 primary criteria that are of interest for reduced sulfur compounds. One of those is the ambient air quality criteria, and the other one is the actual standard. And you can see in this slide here, each criteria has a value, it has an average time that the sample needs to be collected for, and it also is defined, or the limiting effect which defines the regulation is based on either health or odor or a combination of both of those. So as we see here, the first one, hydrogen sulfide, which is one of the most common, there are two different air quality, ambient air quality criteria, 7 and 13, depending on the time, and the standard is defined as 10 based on a 30-minute sample. So and you can see the other compounds that are defined in the regulation. It is interesting that total reduced sulfur has two different values depending on whether it's from the pulp and paper sector or whether it's from one of the other sectors of the economy. There's also a federal regulation. In 2007, Environment and Climate Change Canada added total reduced sulfur to the Part 1A of the National Pollution Release Inventory. Substance lists, often referred to as the NPRI substance list, for purpose of reporting to the NPRI. TRS is composed of 6 compounds, so two additional compounds are added that are in the Ontario criteria, and those are carbon disulfide and carbonyl sulfide. And again, the TRS is a sum of those 6 compounds. In 2014, total reduced sulfur reporting was required, or is only required for releases into air. Hydrogen sulfide, carbon disulfide, and carbonyl sulfide must be reported separately if the target emission limit is met for an individual substance. So the NPRI list is based on the amount of emissions, and if you exceed the limit set for one of these individual compounds, you have to report TRS plus those individual compounds. And the NPRI light limits are higher than those for Ontario because these are based on emission targets, not the air quality criteria. So let's look a little bit now at sample collection. The stability and reactivity of sulfur compounds makes them a challenge to collect and analyze for within the recommended hold time. One option is to collect samples into inert silica-coated canisters, and ideally the sampling train, the valves, the flow control, all should be silica-coated to minimize any contact during collection. The other option is to use tender bags with polypropylene fittings, and you need to protect these from light and heat after the samples are collected. Samples should be collected and shipped the same day overnight to arrive the following morning at 9 a.m. To allow enough time for the analysis. I'm going to talk a little bit about hold time in a minute. To ensure hold times are met, the laboratory should be contacted before sampling. Okay, recommended hold times. If samples are being collected in tender bags, then the recommended hold time is 24 hours. So you can see that makes it a challenge to collect the sample and get it to the lab in suitable time. If samples are being collected into silica-coated canisters, 48 hours is what we recommend. Samples can be collected into a variety of different canisters. If you are collecting ambient air or indoor air samples over 30 minutes or over, and you need a time-weighted average sample, a 6-liter canister would normally be used. If you're taking a grab sample from a landfill or a treatment plant, a 1.4-liter canister should be adequate. And we're also doing work with clients that are collecting high-level samples from tanks and that, and we suggest those be collected into 1-liter glass, so silica glass ball vacs, so that these high samples don't destroy the canisters that they're being collected into. Okay, so for the analysis of reduced sulfur compounds, we are using ASTM method D5504, which is the standard test method for determination of sulfur compounds in natural gas and gaseous fuels by gas chromatography with chemiluminescence detection. Why did we pick this method? Well, there's a few reasons. It's specific. The chemiluminescence detector is an equal molar detector for sulfur compounds, which allows the detection of individual compounds, unidentified compounds, or also enables total reduced sulfur to be calculated based on the sum of the compounds as hydrogen sulfide. The technique, the method is sensitive. Low parts per billion detection limits can be achieved. It has a wide dynamic range and linear response over the calibration range that you're doing. And one of the big things is accurate. Because this method is specific, because of the chemiluminescence detector, it enables you to run a wide range of samples without the interference of the background in the sample. So whether they be air samples or digester tanks or refinery gases or whatever, the method works very, very well. So what are some of the testing capabilities that we offer? Well, we offer individual reduced sulfur compounds. We have a common 10 package, for example. We have an extended 22 compound package. And we can also scan for unknowns in the sample and quantify those against methyl mercaptan, for example. We offer total reduced sulfur as hydrogen sulfide, which has already been mentioned previously. And we also offer a couple of packages, reduced and total reduced sulfur packages that for Ontario, which gives you the individual compounds of interest as well as total reduced sulfur. And for the Environment Canada package, the 6 compounds of interest and the total reduced sulfur summed of those 6 compounds summed as hydrogen sulfide. Okay, this slide sort of highlights our current reporting limits for the 22 compound list, the compounds that are in our list. And the bolded compounds are the ones that are in the Ontario or the Environment Canada list, and they're in bold. And our reporting limits for those compounds are less than the Ontario criteria. So that's good.